All right, so awk. Awk is a pattern scanning and processing language. So what it's going to do is it's basically going to be searching for a pattern that you specify. If it finds that pattern, then it's going to perform the action that you tell it to actually take. Now, it is a data-driven language instead of a procedural-driven language. So there's going to be a source file, and that source file kind of governs what drives the actual code that you write there. So pretty much every time you're going to be using this. Now, you can actually get away, and we'll kind of show that a little bit later on, without having a source file, but you're kind of getting away from the true purpose of what awk is for. You probably might want to use another language. It would probably be more efficient if you don't actually have a source file to drive that there. So it is excellent for filter and report writing. So this right here, awk is very, very good if you're trying to do some pre-processing, trying to strip down the actual file before you actually use it. So you can just use it just for pre-processing. Back when I did my master's program, it was in I think what was that? It was Bernard Chen's the one that taught it, and I can't remember the class now. We were doing clustering, I think it was. Does he teach clustering? Like I said, I haven't had sleep. I can't remember. Anyway, that was actually one of the things. Like, I took all of our huge data set and I wound up stripping all of the data out that we didn't need, making the data uniform. It is really, really quick and powerful for that type of stuff. It's also good for generating reports. We can actually kind of make the reports look pretty and easy to read in there. So 2 good options to use awk for there. And a lot of the files that we actually use within Linux, they're going to be delimited oftentimes by like colons, or you could be working with CSV files. So it's going to be delimited by commas there. So we can actually use awk to kind of strip that down. You can think of it as like an Excel spreadsheet. So we'll take that and we'll turn that whole entire document, even though it maybe has no spaces, we can specify, okay, the delimiter is a colon in there. So every colon is going to be a separate column. So just think of an Excel spreadsheet and that'll make it easier. And of course, some of its operators, they're very similar to C, so they should be pretty familiar, kind of make it easier to pick up. It only supports an associative array. It does not support any type of index, but those are very, very powerful, and you will definitely need to be able to use that to complete some of the tasks on your semester project there. So this is a list of some of the similarities between the C programming language. I like to point out on the printf right here, we will cover printf, I told you, and we're going to cover that today. We're covering it day 4 awk, but I'll also show you an example of how we can use it in bash. There's just a tiny difference between the two. But once you actually learn printf, I actually like printf in awk and bash way better than I like the default print statements in both of these languages. Printf gives you way more control. So there are different versions. So the original was awk, that is on the Unix systems. We'll be using Gawk if you're on bash here. For those that are using Mac, you will be using Mach on here. Now, what we'll do in this is we can actually just kind of use a default way. We can actually just reference awk, and I'll show you how we can do that. So that way it's a little less confusing for the Mac people. So this will be a little bit more uniform, and we can kind of do an experiment here. So if I said which awk, so that way it verifies if it's installed on there. So it says that it is installed. So we can take this path right here, copy that. Then we can do an ls-l and then go ahead and just paste it in there, hit enter. All right. Now, somebody explain to me what is special about this line. What's different about it? If you were trying to explain to somebody the importance of this output, can somebody tell me? Okay, how do we know that? Perfect, and then we have this, right? Okay, and you got it right. It's a symbolic, it's not a hard link. So perfect right there. So now it's telling me that this awk is actually pointing to etc alternatives.awk. So let's go ahead and do an ls-l on that, paste it in here, hit enter, and then look what we get. We get another symbolic link that's now pointing to this file right here. So let's copy that. Again, ls-l here, paste in, hit enter, And now we finally reached it. Here is the actual executable in here. So your Mac is going to do the same thing. It's probably going to be different paths, obviously. But if you use awk, reference awk all the time, it's going to be more portable because then it'll, like on a Mac, it'll just point to mock. And on this system, it's going to point to awk in here. So by default, let's just all use awk. So that way the Mac people, you aren't using Gawk. And then when I run it on my system, it's not going to work. Of course, I could create an alias or install it, but it's to make it a little bit more portable. Everybody use awk and it's going to point to the right place. All right, so here's some of the options to awk. So to actually start running this, all we got to do is call the awk command right here, and then we can give it some arguments. So here is the field separator. So that is going to be like that column. How is the file going to be split up into those columns? And then we also have this -- file program, or sorry, yeah, that's it. No, it's actually -file, sorry. And then you can give it this program file. So what the program file is if you're writing something that's going to be multiple lines, then you don't want to simply just call awk and then write all the awk code after that. You probably want to put it in a file so that way you can, make it a little bit easier to read and come back and edit. So you can just create a text file and then put all of that code into that text file. And then we just call the -f or -- file and then give it the argument of the actual awk code as input there. And then we also have this -- assign. So we're going to be using awk and we're going to be mixing it in a bash script. That's probably the best way to do it. Now, there's multiple ways of doing it. You could write an awk script, have a bash script that then calls the awk script. But I kind of prefer just integrating it all within the bash script, or even maybe doing it this way right here instead of writing a separate awk script altogether, because it allows us a few more options. One of those is to pass variables within it. So this right here is going to be, you kind of give it a name and then equals value. And then we are actually going to be passing that to awk, so we can take a bash, something within bash, and then kind of import it into awk. And what's important to understand is in awk, you can kind of see this var name right here. There is no $sign for variables within awk. You just have the name. That is it. So if we had a bash variable, say we'll just say we created name equals Jacob here. And then we want to actually send this variable to awk, then we could just say, we'll just do f name for first name, and then we could set that equal to $name right here. So now we're taking a bash variable and we're sending it to awk under a different name. Now, you could do the same name if you want to, it's fine, but just know that they are different. When you're going to be referencing that variable within awk, there is no $sign whatsoever. So that's one of the things you're going to have to get used to, is the no $sign within that. And there's also some repercussions we're going to see that's going to make kind of print statements a little bit different. All right, so here is the official kind of syntax for it. Y'all know that I tend to not be, I don't like the official syntax. I like to break it down. So here is the 4 methods in which I've kind of broken it down that you can use awk. So one is you're right on the command line here, and you're going to use awk. I just showed you some of those options. So those options we can pass to awk. Now here is the awk code right here. So just like with the find command, you remember find command had like wildcards and different things. And so we wanted the find to actually process that and not bash to process it. So we put it all within single quotes. So that way bash knows not to read this. So it's going to be the same thing. This is required right here when you're on the command line. You have to differentiate your awk code from bash right there. So all of that code goes within the single quotes. And then we have our source file, and that's that data-driven file. So that's going to drive all of our code right here. Now, there's a hybrid method of that, and that is what I told you earlier. If the code is too much, we don't want to write it all in the command line, then we can create a text file, put all of our awk code within that file, and then we have our option right here that knows that there's going to be an argument of that code coming after it. So we can then kind of import that code in, and of course, give it our source file. Then there's like a third method here, and that is using method 1 and 2 within a script, because everything that we do on the command line, we can do within a script. So both of these right here, we can do that straight on the command line, or we can actually do that right within a script. No difference. And then there's the fourth one right here, and that is actually writing just an awk script, skipping bash altogether. So somebody tell me what this is, and then also explain, like, I guess, what is the term for it, and then what is its purpose? It is the shebang. So what's its purpose? Yeah, so basically, what's going to interpret this right here? So we're saying that awk needs to interpret this code, bash does not. So our shebang has now changed. And then I just put this right here. We'll cover these a little bit later, but understand this begin, this end, it could be in here too, as well in here. And of course, the pattern and action right there can be in there as well. It's just some code just to show you that this is code right there. All right, so there are 3 sections, and they are all optional, and that is the begin. And there's this pattern action. Sometimes it's referred to as just the body, because that's where the main, your main code's going to be. And then they have this end block. So they are all optional, but you have to have one at least, or otherwise it's just not going to do anything. And then we're going to have the pattern and the action right there. And so the pattern, that is our search. So what are we searching for? If we find that pattern, here is the action that's going to take place. If we were to have no pattern, then the action would therefore be performed on every single line of input that we give it. If we were to delete the action, then it's just going to search, and it's going to take a default action, and that default is just print. That's it. So if we just wanted to print, we could simply just give it a pattern, and then boom, it'll just, every time it finds that pattern, it's just going to print to standard output there. So again, kind of the same thing. They're optional, but you must have at least one right here, or the thing isn't going to do anything. All right, so how does this actually work? Well, we have that source file. So that, and I said it's data driven. So by default, if we give it let's say we give it a file that has 10 lines, well, then it's going to go through one line at a time. And then, so it would read in kind of line 1 right there. That's the input. Then it would do a search on line 1. If it finds the pattern, then it's going to do some type of action on line 1. And then it's going to go, okay, I'm going to delete that out of the buffer. I'm going to read line 2, put that in the buffer. And then I'm going to go back to the top of that code. I'm going to search for the pattern. I'm going to do the action, and it's going to do that until it hits line or till 10. And then it's going to look for line 11. It's not going to be there. End of program. Understand, depending on how you code it. So let's say you have a pattern and an action, and then you specify another pattern and action, and maybe you do that, well, we'll just say 2 times right there, and you've got 10 lines that's going to be fed into it. So it's going to have that line 1 in the buffer. It's going to search for that pattern. If it finds it, then it's going to put output, and then it's going to go to the next pattern. And if it finds that pattern in line 1, then it's going to have output. So if you set that up, then you could possibly have 20 lines of output for only 10 lines of input from the source file. But again, it depends on how you code it. And of course, if it finds the pattern or not. All right, so here is a visual representation of kind of that process right there. So we have the begin block. What's important to understand about the begin and the end block, this is more like the regular programming language or kind of like Bash that you've been working with. In other words, we just write code that's in here. There's nothing that automatically takes place. So we control fully this begin block, and it's going to go through that code, and then it's going to move on. And then, of course, it hit the body here. And then after the body is complete, if you have that end block, of course, it's just going to do the end block and then move on. So what is good for the begin block, that is a good place to set up a lot of your variables that you're going to be tracking. It's also a good place if you have like a header, if you're writing a report, put your header in there, because it'll actually go through that. And let's just say we've redirected it to some file, then it's going to go ahead and write that header to the file. And then when it starts getting here, of course, we have an input file. It's going to read line 1 right here, and then it's going to execute all of our commands. And then if, there's more to our source file, there's a second line, then it's simply just going to go back up here and then rerun our code again. And then until it hits, where there's no new line, So that's the end of file. So then it's going to move to the end block. And this is where we're going to do a lot of our summary data right here. So everything we've learned from here, we're going to, probably do some type of calculations or whatever, and then kind of summarize all that. So understand this section right here is a built-in for loop. You don't have to code the for loop. A lot of people that kind of messes them up at first, they'll write their own for loop. So understand, if you write your own for loop, it's now a nested for loop, because by default, it is a for loop that is driven by the lines that are in that source file. So if you were to put, let's just say we create a variable and we're just going to have a count right here. So we're going to say var equals 1, and it's a number or whatever. And if we did that inside of this block right here, and then let's just say we create a pattern, and if that pattern is true, we're just going to say var equals, or not equals, we're just going to do a var plus. So it's just going to increment by 1. And then, so it reads line 1, the pattern is true, it increments it here. So now the variable is actually equal to 1. And then it winds up where it gets down here, discovers there's a new line. So it moves to line 2. Then what's going to happen is it's going to initialize that variable again, set it to 0. So everything is erased. And then of course, if it's true, then it's going to increment it again to 1. So that's why you need that variable declared up here. So it's not going to be overwritten every time that this loop actually occurs right here. Regular expressions. So again, like everything in Linux, there has to be a little slightly different syntax. So when it comes to regular expressions, first, let's define a record. So a record, if we have a source file right here, we have line 1, line 2, line 3 right here. The current record would be what's in the buffer. And understand it's only going to do one line at a time right there. So when we talk about record, we're talking about that first line that it's reading. If we wanted to do a global search on this record, so in other words, just read all the text in that line, then you could put your regular expression within the forward slashes there. But I told you we can split this record up into columns right here. If we're splitting up into columns and we want to actually, we'll just say this is the second column and that's what we want to look at, then you would have to specify the second column before. We'll talk about that meaning a little bit later. And if you do that, you have to put a tilde there. The tilde is going to say, okay, we're searching column 2, and then our regular expression kind of comes after that tilde. So just slashes itself. That's a global search on the entire record. Here, you're narrowing down to a specific column or even a variable. And that's how that goes. And then, of course, we got some of the operators right here. I don't think we need any explanation on those. It does support the double pipe and double ampersand for the or and there. And this right here is just explaining what I told you about how the begin is before and the after comes after kind of the body there. And this is the default action of print, talked about that. And then of course, for comments here, we've got the pound sign. All right, when it comes to variables, you can declare those before, or you can kind of use them on the fly. You know that I like to go ahead and declare all my variables at the top, so I know everything that's being tracked within the code. I think that's better, but it's not required. And of course, if you don't assign it, if it's a number, it's 0. If it's a string, then it's a null string there. Of course, we have user and program variables. We'll cover those program variables on the next slide. They can be used within that pattern and action. So kind of the normal stuff. Now, here are the built-in kind of variables within the system. Of course, we've seen $0 and $1, right? All right, this is an important part. They're all different. So what is $0 in bash? Current script name. All right. Well, what does it say up here? It's the current record. So what does that mean that $0 represents? Yeah, so if we're processing line 1, the current record is going to be line 1. So we can reference that with $0. Now, $1 through $n is the fields, and the fields means the columns. So if we were trying to reference the first column, then we would do $1. And this is the funny part, and it's also a little confusing. These variables have a dollar in front of them, but they are the only variables. There's no other dollar whatsoever. It's only these numbered variables. So don't get confused on that. No other variable. These are all variable names right here. They do not have dollar signs. The file name, so that right there is going to be the source file, the data that actually drives it. So if you want to get the file name of the file that has all the lines that's driving your script, you can just reference file name, and then it'll give you that file name. Then we have FS. So that is going to be, how is this delimited? Is it colon? Is it a comma? And then, well, I'll come back to that. And then we got output field separator. So you can see by default, these are all spaces right here. So let's say that our input field separator is a CSV, and we want to change that whole file to colons. Well, then we could specify the FS is going to be a comma, and then we could specify the output field separator as a colon. Now we just transcribe that.
Do you specify that in the begin, or is there a way to specify that in variables?
You would want to do it in the beginning. That's kind of the whole purpose of that begin block, is setting up all your variables. And then we've got NF here. So that's a number of fields. And again, fields is columns. So how many columns are there? It'll come back with a number that represents how many columns. It's a good way to verify right off the bat if you actually chose the correct delimiters. Then we've got the NR. So that is the record number. So again, if we had 3 lines right here, and if this right here is in the buffer, then NR would just return 1. You know, if 3 was in the buffer, NR would return 3. So it's just the line number that it's being processed. Now we've got this right here, and that is the actual input and output records. So we talked about how a record is a single line right here, but let's just say we have a record and it's separated like that. And then we have more right here. So we've got 2 lines of input, but if I specify my input record to be a colon here, then now I've got 4 records, because I've decided that the new line is not my record. This is a record, this is a record, this and this is a record. So you can change that. And then you could have your 1 record right here, and then your output record, you could actually make it colon separated. So you could actually then have multiple lines of output per single line right there. So you can kind of really manipulate that. Now, if you were paying attention, we've kind of seen some of this, like this FS right here. So if we go back all the way up here, there it is here, -- field separator or --F. And also pay attention to that right there, because that gets a lot of people when they write their code. So if you're doing the shorthand of the field separator, it's a capital F. If you have a whole file full of all your code, that's going to be a smaller F. So understand that on this right here, we're within a bash, shell, right? So this is bash right here, reading this and then importing it to awk. We can do it that way. It's perfectly fine. The method right here is we're within awk itself. And now we're actually using awk code to go ahead and specify that. So you can do it both ways. Just don't get confused right there. All that's happening is that, what is it? The --F for that. It is just importing and then overriding that variable within the awk code.
The one that's being imported from the shell takes priority over, like, if you were to, like, say you did it in 2 places, for one that's gonna
Code would override. Just the order of operation right there. All right, so there are many functions in this. Of course, we're just kind of scraping the surface with this right here. So I'm just pointing out some. And then if I could point out probably the ones you need to learn, of course, the length right here. So if you give length an argument, then of course, it's just going to get the length of whatever you give it. If you give it no argument, then the length of the current record. So just however long that record is right there. This right here is pretty useful right there. Let's see, these right here, very useful right here. What's something that we've learned that can do the 2 lower and 2 upper? Have we done that in the past? Translation. So we could do that. We could do it before if we wanted to, using the TR command, Or if we want to, we can just combine it right here into the opcode and do that. So you're getting multiple ways of completing the same thing. Not covered in here, but there's also a thing called GSub. I've seen several students that actually use that. Its syntax is pretty atrocious, but it can make some short work of some of the stuff in your semester project. But again, you have all the utilities and tools that you need to not do it, but it allows you to kind of combine multiple steps all into one thing within awk right there. The next command is pretty good. So that, let's say you set up multiple patterns. So if this pattern is true, then this action happens. And if this pattern is true, then this action. But let's say that you don't care if all the patterns, you just care if one of those patterns exist. So if one of them is true, then you don't care anymore. Well, then you could specify next after your pattern. And so if the first pattern is true, then it'll hit next, and then it will just quit reading record 1 and it'll move to record 2. And let's say that pattern 1 is false, then it moves to pattern 2, and if pattern 2 is true, then it hits next and just moves on to the next record. So it's kind of a way that you can trigger those and not process everything there. Here's a list of operators. We're not going to go through those. Y'all should be pretty familiar with that. Nothing's changed on those. Of course, associative arrays, here's kind of your syntax. You have your array name, you give it a key, and you give it a value. Note all of that white space right there. When it comes to variables and arrays, you put white space in between them right there. So very different from Bash. Bash has them connected. Awk does not have them connected there. And then that's just an example of you looping through that array. We'll have another example here in a minute. So here's creating one. We're doing this in the begin block. So this right here is a perfect example. I'm not using that pattern action whatsoever. I just put all of my code in a begin block because I'm actually not using a source file to drive that. Again, you could do this in another language. So I'm just showing that you can do it. So here we have our begin block. We set up the name of our array. We give it a value, and then here we give it a key, and then we give it a value. And then I'm using the print statement. That's, that's kind of like the echo in Bash. And then I'm just calling the fruits and then giving it which one I want. And then I'm giving it the /n here, and you can see our output. So some key things to note from this. One is we don't have double quotes in the print statement like we do echo. The reason is because there's nothing to distinguish our variables from just regular text here. So only strings get quoted within it. So understand you could have like multiple strings, some more code, and then some more strings over here. It gets pretty ugly looking, but that's how it has. Anytime you have a variable, it cannot be within the double quotes because that is nothing but strings in here. Let's see, is there anything else to point out? There was something else and I can't recall. Oh, yeah, I guess it was just the fact that /n, even though it's within, the double quotes, it has special meaning. So we don't have to do any type of like -e or anything to get that. It's just built into print. It understands all of those special characters right there. And then in this second one here, I'm just showing you basically how to delete right there. So you can see we have the same array being declared. Then I just use the delete and reference the actual item in the array. Then here I try to print it and I get no output there. And then also noting right here that each one of these, I'm putting all that opcode because we're right on the Bash terminal right here. So I've got to be able to say, hey, Bash, don't read this. Here is the simulated multi-dimensional array right here because they do not actually support that. And you can see all that we're doing is giving it kind of this double key. It's just a string right here, 0, 0, 0, 1 right there, but it's still just a flat array. And of course, then we just give it that as its key right there. It's just a string right here, but that helps kind of set things up a little bit. And then right here in our print statement, of course, right here, I've got double quotes. So you can see that it's nothing but a string. And then here that it's not within double quotes, that array. And then we're actually getting its value there. All right, so printf. Printf is awesome. I love printf. So its syntax, of course, we just replace print with printf. We replace echo with printf. In double quotes, we have this format string, and this format string is going to have, it's not that, it's a percent sign. It's going to have these placeholders that have percent signs in them. For every single argument that you feed in, it has to have a matching percent sign, and it'll have to have what that data is. And we'll see that on the next slide. So in this case, we'll say this is a string. So the placeholder is the percent sign, and then the type of data being fed to it, S for string there. And then note how you've got the comma separating the format string with the arguments, and then how every argument is also separated with a comma there. And then, of course, it also supports all those special characters within the format string. So here you can mix like just regular string data with your placeholders. So this is where you'd create your whole entire string. And instead of the actual data right here, you would just use the percent signs to import the data that changes. So here is those percent signs, the explanation for that. So again, this is required, the percent sign, and then this type of conversion, which is this list right here. So decimal, float, string, that's really the only ones we're going to need for this class. And then all of this stuff in between is optional. So by default, all of the text is going to be right aligned. So if you want left aligned, you would put a dash in front of it. So you'd have percent dash, and then if it was a string, if you want it left aligned, so a percent dash S, all touching there. And then if we have a number here, or not a number, but any number or a string can use the X right here. So that's just the field length. So that's padding. This is going to help us to be able to format things all in a nice column right here, because we'll specify like, this string has, 10 padding. So it'll take up 10 spaces, whether if it's 3 characters, 2 characters, or 10 characters or whatever. Now, when it comes to numbers and we want to actually have decimals, then you can do this point right here and then just give it a number. So if you wanted to have two numbers after the decimal, then you just do a .2 there. Let's look at some examples here. Right here, I'm showing you the difference between bash. It's very, very small, but of course makes a huge difference because it won't work. And that is the commas on each of them. So you can see our format string here, no commas. We can have argument, 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 all just separated by spaces. But when it comes to awk, the format string and every single argument after that has to have a comma separating. That's the only difference between the two. It'd been really nice if they would have made them the same, but they didn't. All right, so here is our example. So we're note that we are in bash at this point. So we're using the declare keyword, and I'm just setting up 2 variables, actually 4 variables there. And then I'm using printf, and here we have the double quotes for our format string. And then I'm saying the percent sign, so that's my placeholder. I'm saying it's left aligned. It's going to have 7 spaces of padding, and it's going to be a string. And then I've got another one right here, and I'm just saying this is a string, and because there's nothing coming after it, I don't care how much space it takes up. It just doesn't matter. And then I'm giving it a /n right there. So you do have to tell it when you want a new line in here. Otherwise, it's not going to put a new line. Then you notice I have space. I don't have anything else. And I have this name right here. And this looks weird. And I put this in here just to kind of show you a point, but I probably should include another one without it. That is not required. And if you actually look at the output, this is just one of those weird tricks that you can do. Because these are special characters, you can actually tack them on right here, and it counts as one argument, and it's smart enough to know that this is a variable with a value, and this is just a literal comma. So that's how I'm getting away with that. If I was to put it right here, which by default, that's what my brain wants to do, and it's how I normally do things, but because I did this left alignment, which scoots everything to the left, and then let's say I have something that's only 3 characters, but we've got 7 characters long, then my comma is going to be like way out here and instead of butted up against it. So it's just one of the little tricks you kind of have to get used to with printf right there. You can actually take some of these special characters. Now, if I was to put it right here, it would think this is an argument, but the fact that I butted up against that. Now, here we've got an awk script. So again, everything, we have our format string right there. So everything is comma separated. Here I'm mixing an actual literal string. So I got percentages using, and then I have my placeholder right here. And then every one of these, also note that this is literal. So as I type it, it's going to have a space here, space here. It's even going to have a space right here in between that percent sign right there. And then of course we have our percent sign, which is a number, and then a new line right here. And this one right here, because it's floating point and I feed it that number, also this could be some type of variable right there. And it would still work, or it could be a little literal string. But you can see my output is going to be 80.66 there. So a matter of fact, if it was this right here, then because I did the .2f, I'm still, well, actually it would be 67 at that point. It will round up for us. And then versus if I just declared at a decimal, then it's just going to cut that off right here. And now you can see in this one, I went ahead and did 14 spaces right here. So now you can see what that did is this is the spacing. It took all the way up right to this point right here. So that was our 14 there. And actually, no, it's not 14. Gosh, this right here is the 14 part. It does not care about this because here is the actual placeholder. So this is the 14 characters. This is the 14 characters right here. And note that decimal is shorter, but it went ahead and popped everything out right there for us. Made it nice and in line. So when it comes to your reports, you're definitely going to want, I will grade you on the format. So I'm going to have very specific formatting that takes place. You need to make sure that you understand that and how to use the printf for it. Let's see, in this example, I'm just kind of showing you just to prove a point on all the padding right here. So you can see we've got our variable set up. We got a print statement, and then we've got num1, and then we have a padding of 10, and then we have a new line right there. And you can actually, let me discard that. If we went in here and we did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number we fed in was 10. But note how it ended right here. And the reason why it ended right there is because in here, after the equal sign, there was a literal space right there. So that counts as 9. Just kind of showing you how that you actually have to account for that in your spacing there. And then here we have left align. And because that's left align, you know, the end, which gets put in right here, you know, it's all the way out here on that. So here's showing you how you can kind of prefix some symbols there. This is how I tend to like to do this right here. You can see how I did I did the negative sign in front of it. But again, depending on how you're actually padding that, it may or may not work. Sometimes you may have to put them out here, but you can put them in there and it's okay. All right, so just showing you the syntax on the control structures here. So we've got the condition that's in parentheses, and then kind of our action that's going to take place is in the braces right there. So right here, this would be kind of your normal syntax, but note that if you have a simple one, in other words, if you can fit it all on one line here, you don't have to actually put those braces. But I like to put the braces because that's another thing I have to remember, but you need to know it because a lot of people on the internet, if you read code, they'll be doing that right there. And then of course, here's just an example right here of a condition, if I can get it out. And of course, it's using that simple syntax right here. And then we have an else in there. And so it's just going to kind of run through. Of course, this is going to fail right here, but here we have our while, same thing, just while. Note that there's no like keywords like do and done or anything in here. You know, it's just pretty simple syntax, kind of a more modern syntax than what Bash is. And then the for loops, it uses the C style for loops. So y'all should be familiar with that. And then in here, I'm just giving an example of printing an array right here. So again, this would be the key right here that's going to be printed out every time. And then here's the actual value being printed out. So kind of an example of printing both of those. And then we have break and continue, and they work the same way if you can use those in your if statements there. So if something's true, you can break out of the for loop. Sorry, I said if statements. You can break out of the for loop or the while loop or continue on there. All right. Is that all clear as mud? Are you more confused now than when you walked in? All right, don't worry if you're confused at all, because we're just going to spend the entire next class on the command line, just doing example after example. And you are going to want to be here because there are some things in there, kind of some nuances that I will show you within the auth code that I don't really have in the slides there. So we're just going to spend an entire day in nothing but the command line on Thursday, walking through scenario after scenario. And then it becomes a whole lot clearer after that. So, all right, any questions? All right, well, I will see y'all on Thursday.
I said, this feels like it's left. I got it done on water. I made the one second.